Hi, in this video, we're going to be talking about the graphs of sine and cosine. If we think about our golden nugget and these values for cosine and the values for sine, when we get into the next quadrant, all that happens is, at least for sine, they stay the same. Cosine becomes negative, but the values stay the same. They just have a negative twist or a positive twist to them. If we took that idea and then graphed what was coming up, cosine would start at 1, the cosine of 0 being 1, the cosine of pi over 4 being the square root of 2 over 2. Then pi over 2 cosine drops down to 0, and then this pattern sort of emerges where it makes this cool wobbly thing. You can narrow it down, so really what's happening is cosine has a pattern of starting up, then going on the axis, then down below it, then on, and then up. It's always going to be 4 ticks out, and it's always going to go up, on, down, on, up. Something similar happens with sine. So sine starts on the axis and then moves up uh, as we get bigger values for our radian measure, and then shrinks down below the axis and then back up. We can do that same sort of simplification. Oh, wrong direction. Um, for sine, it goes on, up, on, down, on. You can see this also if we were to graph it on our graphing calculator. You can see sine wobbles and wobbles, and as we zoom out, that wobble happens over and over and over again as we spin round and round and round our unit circle. Same thing happens with cosine. Don't bite me. Same thing happens with cosine. Cosine wobbles over and over and over and over again because we go round and round and round and round our unit circle. So with those graphs of sine and cosine, we're going to be doing some transformations to them. If we start incorporating other numbers, what happens to our graph? The number that's on the outside, that first one, is A, the amplitude. So that tells us how tall our wobbles are. So they'll either be really tall or they'll be really short. And then how long it takes to complete that wobble, that is our period. So how long until one of those wobbles repeats? We get this cool little formula for it. It is 2 pi over the absolute value of b. Let's do an example. In this example, we've got the sine of 4x, so that 4 is in the b spot, but it doesn't tell us actually what our period is going to be. So our period for b is, well, b is 4, and then we do our cool little formula, 2 pi over the absolute value of our b, which is 4. So that is going to be pi over 2. So that's how long it's going to take for us to complete that wobble. I've drawn a little sign up at the top there. Normally, it takes all the way until 2 pi for us to complete our wobble. This wobble is going to be all the way done by the time we hit that first tick mark on a regular sine. Our A value is going to be 1 because there's an understood 1 right there. So to make sure that we can actually see what's going on, that top graph doesn't look very nice. We always go out 4 ticks. So 1, 2, 3, 4, and then you write whatever your period is. In this case, pi over 2. And you could figure out what all the little tick marks are going the way down, but you just need to get the most close one, or I'm sorry, the halfway one. So that's going to be half of pi over 2, which is pi over 4. Our amplitude is 1, so that tells us from the x-axis we want to go up 1 and down 1 to negative 1. And then we follow our pattern for sine. So we go on, up, on, down, on. And then we draw our little curve through it. If we wanted to, we could make more periods, but most of the time we only are required to do 1 unless told otherwise. But it's just a matter of continuing that pattern for sine being on, up, on, down, on. In this example, we're dealing with cosine. We've got another b value. This b value is 1 over 4. We do our cool formula, r, how about p? We do our cool formula for our period, which is 2 pi over whatever our b value is, which is 1/4. And it's an absolute value, but that's not going to really do anything. So dividing by 1/4, that's the same as multiplying by 4. So our period in this case is going to be 2, how about 8 pi? So it's going to take a lot of pi's for us to complete. If we looked at this one up here, where we've got 2 pi, we've maybe done our up and on. So we've done very little of our actual graph. Our a value is going to be 1 because there's an understood 1 in front of that cosine. So that we can actually see it, we'll make our own graph over here to the side. We always go out 4 tick marks, 1, 2, 3, 4, and then boom, you write your period, 8 pi. We want to do the halfway one, so halfway between 8 pi and 0 is 4 pi. And our amplitude is going to be 1, so we're going to be going up to 1, and our lowest that will go is -1. The pattern for cosine is our pattern for cosine is up, on, down, on, up. So we'll go up, on, down, on, and then up. And then we want to do our curve through those points. Now, note how the ends, I'm kind of like continuing them on in the direction that they're going. If I were to continue this pattern, my next point would be on. So I want to have the arrow going down. Same thing on the other side. If I were to do the pattern backwards, my next point would be on. So I want that pointed down. You don't want them pointed up like that, because that's like making it look like it's a U. It's a wave, just like sine is. In this example, we have an amplitude, so we want to make sure that we stretch how tall our thing is. Based on our regular sine graph, it's just going to be the same pattern, but it's just going to wobble much taller than it would normally. So our a value is 4, so that's telling us how far up and down we are going to be going. That is our amplitude. We do still want to think about what our b value is. Our b value is 1. So we've got 2 pi, well, b value is 1. So our period is going to be 2 pi over whatever our b value is. Absolute value of it, if it matters, it never matters. So 2 pi over 1, well, that's just 2 pi. So it's going to take the same number of ticks, or the same distance lengthwise as it would normally. 1, 2, 3, 4. Write your period. 2 pi. Halfway point. Pi. And then we want to think about how high and low we're going. Well, we're going up 4. Well, oops, that was a bad tick mark. Let me see, make that a little better. 1, 2, 3, 4. So we're going up 4 according to our amplitude, and we'll also go down 4 for our amplitude. It's not how tall the whole thing is. It is how far from the middle we're moving up and how from the middle we're going down. Our pattern for sine is to start on our axis, then go up, then on, then down, and then on. So there is our curve for sine. It's just taller than it would be normally because we have an increased amplitude. In this one, we've got an amplitude that has a negative on it. So we still have 3. We're going to go up and we're going to go down 3. But we need to flip what we would do normally because we have that negative. So normally cosine starts up, but instead it's going to start down, then go on, up, on, and then down. We just want all those points to be upside down from where they would be normally. Our b value is right next to our x, which is 1. So our period is going to be 2 pi over b, which is 1. So our period is just 2 pi, no change into it. I'd still like to write it just out of habit. That nice muscle memory helps me out. 1, 2, 3, 4. Right, the period, 2 pi. So our amplitude is 3. So I want to go up 3. 1, 2, 3, down 3. 1, 2, 3. So that's my amplitude. Going from the middle. And then I want to follow that new pattern. Now that I'm negative, normally I would start up for cosine. Instead, we're going to start down for cosine. So down, on, up, on, down. And then draw the nice curve. Oh, I missed that last one. Let me try that one more time. Note that these are not sharp. They are curvy. The best that you can. I'm mostly checking those dots and that you're finding those values. In this one, we're going to need to deal with both an amplitude and a period. Well, that's no problem. We'll just deal with them. We've kind of been always dealing with them anyway. So our amplitude is 2, so that's how far up and down we'll go. Our period, well, I don't know. I got to figure out what 2 pi over b is. So 2 pi over 3. So our period is just 2 pi over 3. Okay. Now that might sound like a scary number, but that's not going to change what I do. I still draw 4 tick marks. 1, 2, 3, 4. And I write whatever my period happens to be. I don't care what it is. So 2 pi over 3. Done. Just do it. I want to cut that in half. So I've got 2 pi's over 3. So if I cut that in half, I only have 1 pi over 3. So I'll put pi over 3 right here. Easy. My amplitude is 2. So I want to go up 2 and down 2 from my axis. So -2 and +2. And then follow my pattern for cosine. Cosine starts up. So I'll go up, on, down, on, and then up. Woo! Whoop. There we are. And that's it for amplitude and period. Reminder that pattern for sine and cosine. Sine starts on, then up, on, down, on. And then cosine is going to start up. So up, on, down, on, up. For period, make sure that you remember that cool little formula, 2 pi over b. Very easy to forget that. Well, it's an easy formula to remember, but make sure you remember it. Otherwise, you'll be a bit snookered when you're trying to figure out what your period is. Thanks for watching. Bye-bye.